Okay, in Chapter 9, number 11, the problem is a random sample of 16 individuals is selected from a population with a mean of 70, and a treatment is administered to each individual in the sample. After the treatment, the sample mean is found to be 76 with an SS of 960. Now see, we don't have the data to calculate that, but they've just given us the value. Now for part A, that's pretty simple. What we're looking at is we're looking at the difference between the treated sample and the population mean, which is just this. And of course, we look up here, and that's 76 minus 70, and that equals 6. Okay, part B is how much difference is expected just by chance between the sample mean and its population mean. That is, find the standard error for M. In the hypothesis test, this value is the denominator of the t statistic. And of course, this is how we calculated the t statistic right here. And we've already done the top part, and now let's take a look at and find the standard error of this mean. So let's see the things that we know. We know that the SS is 960, and we know what the number is, the sample is n equals 16. So let's take a look at this equation right here, which is s squared variance equals ss divided by n minus 1. And of course that is the same sort of expression as this one. S divided by n divided by 1 squared. So let's look right here. So this is the same thing as 960 divided by n minus 1, which is 15, and that is 64. Now we know what we need to know to calculate SM. SM equals S divided by the square root of n, and that's 8 divided by the square root of 16 equals 8 over 4 and that equals 2. And that is the answer to part B. Oh, for part C, we're going to look at this, and this is again a two-tailed test. And so we'll notice that alpha is going to equal 0.05, and that means that both of these tails are going to be 0.025. And so we again look up in our table And for our degrees of freedom, it's going to be 16 minus 1, or 15. So we look up at the degrees of freedom is 15, and we find our T critical. Is going to equal plus or minus 2.131. Okay, now for our t-test, we've already calculated these two items. So let's take a look at that. And so we've got m minus mu is 6. And SM is 2. 6 minus 2, 6 divided by 2 is 3. And 3 is greater than 2.131. Now, we might want to take a look at the Cohen's d expression, which one problem with this hypothesis testing is that it tells you whether a change is significant or not, but you could have a very small change and have it be very significant, especially if you have a large population. So we notice that the expression for Cohen's d is m minus mu divided by s, and that we've already calculated those numbers, is 6 divided by 8 equals 0.75. Now if you look on page 233, you can see a table that identifies the significance of the Cohen's d values, and we can see on that table that 0.75 is a fairly large change. So I'll let you take a look at that.